Most students who learned how to factor learned with an AC method. I do an AC method, but I do it backwards. Um, and the only reason I do is because, yeah, students that didn't grasp it before, maybe they can grasp it this way. I'm also going to show you the cheat for how to factor this. But the classic way is to say, okay, factors of minus 18 that add up to positive 7. And right away, maybe you're saying 9 times minus 2. And I would, when in doubt, I would just say, okay, I'm playing around with that 2, 3, and the 3. And it's actually the 18 times minus 18 times the 1. 2, 3, and 3 to try to get something to 7. And you can see the 9 minus a 2 there, maybe. And here's one way to achieve the factorization. Factor by grouping. Once you've decided that 9 times minus 2 is the way you're going to do it, here's one way to achieve the factorization. And so let's see. I got a common factor of x in the first two terms. See how I turned the 7 into a 9 minus 2? Yeah, so x times x plus 9 on the next line. It looks like I can factor a negative 2 out of the next two terms. And minus 2x over minus 2 is a positive x. Minus 18 over a minus 2 is a plus 9. Now I got a common factor of x plus 9. I can pull that out. And once I've got it factored, look, we're all talking about real numbers here. And here's the zero product principle. Anytime a times b equals 0, then a equals 0 or b equals 0, right? So this is telling us that either x plus 9 equals 0 or x minus 2 equals 0. And most students who've done their obligatory first 100 of these, they can go straight from the factored form and say, oh, yep, x has got to be negative 9. Oh, yeah, x has got to be a positive 2. And a nice way to write this, x belongs to the set minus 9, 2. Okay, but what if the teacher wants to see the factoring? When they say use factoring, they're really expecting to see that and for you to reason from that to the zeros. But you know what? You can just as easily reason from the zeros back to the factoring. If I know that x equal minus 9 makes it 0, I know that x minus a minus 9. See, x minus a minus 9 there. X minus a minus 9 is a factor. If I know that x equal 2 makes that thing 0, I know that x minus 2 is a factor. So I can go from the zeros back to the factors really easily. So when in doubt, get out your get out your sledgehammer. Um, a equals 1, b equals 7, c equals minus 18, b squared minus 4ac is 7 squared minus 4 times 1 times negative 18. And that's 49 plus, let's see, 36 times 2 is 72. And that looks like 121, and 121, my friends, is 11 squared. So x equals negative 7 plus or minus the square root of 121 divided by 2 times that a, which was 1. And so this is negative 7 plus or minus 11 divided by 2. Negative 7, I'm going to go this way. Negative 7 plus 11 divided by 2. And that's 11 minus 7. That's 4 over 2. That's 2. So 2 makes it 0. And then minus 7 minus 11 divided by 2. That's equal to minus 18 over 2. That's equal to minus 9. Oh, look, minus 9 and 2 make it 0. So x minus 2 times x minus a minus 9 is how it factors. And then maybe you want to hide the evidence and say x minus 2 times x plus 9 equals 0. That tells me that x is either negative 9 or positive 2. And then just hide all this stuff. You won't have to hide all this stuff from me. If you have made the connection between zeros and factors, just like I've shown you here, you're already a good deal into chapter 3. And you're not wasting time trying to learn this intermediate algebra skill with which so many students struggle, and which is of very limited utility in the actual real world.